February 19th, 1943. The desert sun beat down mercilessly on a makeshift German field workshop outside Kasserine Pass, Tunisia. Inside a canvas tent that offered little respite from the heat, Hauptmann Klaus Richter knelt beside an object that made no sense. It was a simple steel tube, nothing more. 5 feet of hollow metal, open at both ends, with a wooden stock bolted to one side and crude iron sights welded atop. No breech mechanism, no recoil dampener, no precision engineering whatsoever. Just a pipe. "This is the American anti-tank weapon," Richter muttered, running his fingers along the seam where the tube had been hastily welded. His voice carried equal parts disbelief and something closer to dread. Beside him, Leutnant Werner Vogel turned the rocket over in his hands. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The projectile was equally crude, a finned tube with a bulbous warhead, no larger than a man's forearm. Its construction was so unsophisticated that Vogel could see the spot welds where the fins had been attached. "It looks like something assembled in a tool shed, Herr Hauptmann. Surely this cannot penetrate armor." But it had. 3 days earlier, during the German counter-offensive through the pass, American infantry had knocked out 2 Panzer III's with weapons exactly like this one. The crews who survived spoke of rockets screaming from nowhere, punching through side armor as though it were tin, transforming their machines into furnaces within seconds. Now, headquarters in Berlin wanted answers. They wanted to know how a nation that had entered the war barely a year ago could field a weapon this effective. More importantly, they wanted to know why Germany, with all its engineering prowess, had built nothing like it. Richter stood, wiping sweat from his brow. An engineering officer by training, he had spent the last decade refining anti-tank weapons for the Wehrmacht. The Bazooka 39 anti-tank rifle, a 20-pound monster that required superhuman strength to carry and barely scratched modern armor. The Bazooka 41, marginally better, but still obsolete against anything heavier than a light tank. Germany's answer to the armor problem had always been the same: bigger guns, heavier rifles, more complexity. Yet here was America's solution: a tube, a rocket, nothing more. "Bring me the technical specifications from our anti-tank development team," Richter ordered. "Everything. The Panzerbuchse program, the experimental shaped charge grenades, all of it. I want to understand what we've been doing wrong." The comparison was immediate and damning. Germany's smallest man-portable anti-tank weapon, the Panzerbuchse 41, weighed 35 pounds loaded, required a 2-man crew just to transport, fired a 13mm tungsten core round that could barely penetrate 50mm of armor at point-blank range, and cost nearly 200 Reichsmarks to manufacture. Its effective range was 100 meters. Beyond that, the round simply bounced off. The American bazooka, by contrast, weighed 13 pounds. A single soldier could carry it. Its M6 rocket used a shaped charge warhead that could penetrate 75mm of armor at ranges up to 150 meters, and according to the markings Richter found stamped on the tube, it cost roughly $40 American to produce. At current exchange rates, that was less than 100 Reichsmarks, half the price, triple the effectiveness. Vogel laid out schematics he'd drafted by hand, crude drawings made by measuring every dimension of the captured weapon. "The ignition system is electrical, Herr Hauptmann, a simple dry cell battery in the wooden stock, connected by wire to terminals at the rear of the tube. When the trigger is pulled, current flows. The rocket motor ignites, and the projectile exits at roughly 85 meters per second. Show me the rocket motor." Together they disassembled one of the captured rockets, cutting carefully through the thin sheet metal casing. Inside was a solid cylinder of propellant, coarse-grained and unsophisticated. Nothing about it suggested advanced chemistry or precision manufacturing. It was, Richter realized with growing unease, designed to be made quickly, in vast quantities, by workers who needed minimal training. The warhead told an even more troubling story. Germany had experimented with shaped charge technology, hollow charge explosives that focused the blast into a penetrating jet capable of punching through armor far thicker than the explosive's own diameter. But German-shaped charges required precise machining, careful assembly, specialized detonators. They were complex, expensive, suitable only for specialized munitions like the heavy Panzerfaust or artillery shells. The Americans had simplified it. The bazooka's warhead was a cone of copper backed by high explosive, nothing more. When the rocket struck a target, a simple contact fuse detonated the explosive, transforming the copper liner into a superheated jet that burned through steel like a torch through wax. Effective range didn't matter beyond 100 meters because at that distance, the rocket hit with enough force to guarantee detonation. Accuracy didn't matter because the warhead was so effective that even a glancing blow could disable a tank. It was crude. It was simple. It was brilliant. They've removed every unnecessary element, Richter said quietly, more to himself than to Vogel. Look at our panzer books: bolt action, rifled barrel, precision sights, tungsten core ammunition manufactured to exacting tolerances. Every component designed for accuracy at range. But accuracy is worthless if the projectile can't penetrate when it arrives. The Americans chose effectiveness over elegance. They chose pragmatism over pride. Richter set the disassembled rocket down carefully. This weapon wasn't designed by engineers trying to perfect a solution. It was designed by engineers trying to solve a problem. There's a difference. The historical context made it worse. In 1941, when Germany had invaded the Soviet Union, Wehrmacht infantry had faced T-34 tanks, whose sloped armor shrugged off anti-tank rifle fire as though it were rain. Commanders had screamed for better weapons, portable solutions that could stop Soviet armor without requiring soldiers to carry 80-pound anti-tank guns across the steppes. The response from German ordnance departments had been predictable. Heavier rifles, experimental recoilless guns, promises of future developments that never quite materialized. Meanwhile, America had entered the war in December 1941, faced the exact same problem, and solved it within 6 months. The first M1 bazookas had been rushed to North Africa in November 1942, barely tested, still plagued with reliability issues from faulty batteries and unstable rocket motors. Yet even in their earliest, most primitive form, they had proven more effective than anything Germany fielded. Richter pulled a captured American field manual from his bag, printed on cheap paper with simple diagrams. The instructions for using the bazooka fit on 2 pages: load rocket from rear, connect wire terminals, aim, fire. Safety precautions occupied more space than operational procedures. It was designed to be operated by farm boys and factory workers with minimal training in the chaos of combat under fire. Germany's anti-tank weapons required trained specialists. The Panzerbuchse needed marksmen who understood ballistics, trajectory, armor angles. Even the experimental Panzerfaust, still in development, required careful handling and precise timing. The Wehrmacht's philosophy had always been to create superior weapons that, in the hands of superior soldiers, would overwhelm the enemy through tactical excellence. The bazooka revealed a different philosophy entirely. America wasn't training superior soldiers. It was training adequate soldiers and giving them superior tools. Tools so simple that adequacy was sufficient. Tools produced in such quantities that losses didn't matter because replacements arrived faster than they could be destroyed. "I need to see production capacity," Richter said. "American industrial figures. How many of these weapons are they manufacturing?" The intelligence reports made for grim reading. General Electric had been awarded the initial contract in May 1942. Within 30 days, the first production models were rolling off assembly lines. By November, 15,000 had been shipped to North Africa. By the end of 1943, projections suggested America would produce over 300,000 bazookas and more than 10 million rockets. Germany's entire Panzerbuchse program, spanning 4 years, had produced fewer than 200,000 rifles total. If you find this story engaging, please take a moment to subscribe and enable notifications. Vogel did the mathematics aloud, his voice flat. If current projections hold, by the end of this year, the Americans will field more anti-tank weapons than we have infantry squads in the entire Wehrmacht. And their weapons will be twice as effective as ours, Richter added. At half the cost, in half the time. The tent fell silent except for the whisper of wind against canvas and the distant rumble of artillery. Both men understood what the numbers meant. This wasn't about a single weapon system. It was about industrial philosophy, about how a nation approached war. Germany built masterpieces, finely crafted instruments of war that required skilled labor and precious materials. America built tools, simple and effective, produced in such overwhelming quantities that quality almost became irrelevant. "We need to test it," Vogel said finally. "Fire it against German armor. Confirm what the Americans claim it can do." They requisitioned a captured Panzer III, one of the tanks knocked out during the American retreat through the pass. Its crew had abandoned it after a thrown tread, leaving the vehicle otherwise intact. Richter positioned it 200 meters downrange, angled to simulate defensive positions, and loaded the captured M6 rocket into the bazooka. The weapon felt wrong in his hands. Too light, too simple. The wooden stock pressed against his shoulder, the iron sights lined up with the tank's turret, and when he pulled the trigger, the battery sent current crackling through the wires. The rocket motor ignited with a whoosh, not the sharp crack of a rifle, but a sustained roar that built for half a second before the projectile left the tube. Smoke billowed around Richter, hot exhaust washing over him, and the rocket streaked forward, trailing fire and white vapor. It flew straight, wobbling slightly from fin stabilization but holding course, covering 200 meters in just over 2 seconds. Impact. The warhead struck the Panzer III's frontal turret armor at a shallow angle and detonated instantly. The shaped charge fired its penetrating jet through 50mm steel, as though the armor weren't there, and the interior of the tank erupted in flame. Secondary explosions cooked off stored ammunition, and within seconds the entire turret was engulfed. Richter lowered the bazooka, staring at what he'd done. From trigger pull to destroyed tank, 3 seconds. A farm boy could have done it. A clerk could have done it. Anyone strong enough to lift the weapon could have killed that panzer from a distance that rendered return fire almost impossible. "Herr Hauptmann," Vogel said carefully, "we cannot match this." "I know. I mean, we cannot match it technically, industrially, or tactically. Even if we copy the design exactly, we lack the manufacturing capacity to produce it in the numbers they can. We lack the raw materials. We lack the logistics to distribute it. And we lack the training infrastructure to field it effectively before—" "I know," Richter repeated, his voice harder now. "I know what this means." What it meant was simple. Germany had spent years developing anti-tank weapons that required specialist training, expensive materials, and complex manufacturing. America had spent 6 months developing a weapon that any soldier could use, made from basic materials, assembled on mass production lines. And the American weapon was better. The implications stretched beyond anti-tank warfare. If America could do this with a bazooka, what else had they simplified? What other weapons systems had they reduced to their essential functions, stripped of unnecessary complexity, designed for production at scale rather than perfection in form? Richter thought of the panzer tanks Germany took such pride in engineering masterpieces with superior armor, better guns, more sophisticated fire control systems. But they took months to build. American Sherman tanks, by contrast, rolled off production lines at rates that defied belief. Crude, unreliable, vulnerable, but produced so fast that losses didn't matter. For every panzer destroyed, 5 Shermans took its place. The same philosophy. Effectiveness through quantity. Pragmatism over pride. "We'll send the complete analysis to Berlin," Richter said, gathering his notes. "Full technical specifications, test results, production estimates. They need to understand what we're facing." "And if they don't listen?" Richter looked at the burning panzer, black smoke rising into the desert sky. "Then we lose this war not because our soldiers lacked courage or our generals lacked skill, but because our engineers lacked humility, because we built what we wanted to build instead of what we needed to build." He turned away from the wreckage, walking back toward the tent. Behind him, the fire consumed what remained of German armor while American simplicity burned, victorious. The desert sun beat down mercilessly, and Hauptmann Klaus Richter carried the weight of knowledge that some truths arrived too late to matter. The war had shifted, not in a single battle or a dramatic offensive, but in workshops and factories where design choices determined outcomes long before the first shot was fired. Germany had chosen complexity, America had chosen simplicity, and in the calculus of industrial warfare, simplicity multiplied by millions would always defeat perfection multiplied by thousands. Inside the tent, Vogel was already drafting the report that would travel up the chain of command to Berlin, to officers who would read it and dismiss it, and continue building their masterpieces while America flooded the battlefield with tools. Good enough tools, produced fast enough, in quantities large enough to drown any opposition. Richter sat down heavily, staring at the simple steel tube that had changed everything. A pipe, a rocket, nothing more. Yet in its crude simplicity lay a lesson Germany had failed to learn, and now, surrounded by enemies on every front, would pay for with blood and defeat. The bazooka wasn't just a weapon, it was a mirror, and in its reflection, Klaus Richter saw the future of warfare, where ingenuity mattered less than capacity, where craftsmanship gave way to production, where the nation that could build the most won, regardless of who built the best. He picked up his pen and began to write, knowing the words would go unheeded but writing them anyway because someone had to tell the truth, even if that truth arrived like a rocket through armor too fast, too late, and far too destructive to ignore. The report reached Berlin within a week, carried by courier through military channels that treated technical intelligence with the same urgency as battlefield dispatches. It landed on the desk of Oberst Heinrich Müller, chief of the Wehrmacht's Weapons Development Division, a man whose career had been built on transforming theoretical designs into practical instruments of war. Müller read Richter's analysis twice, the second time more slowly, pen in hand, marking passages that contradicted everything German military doctrine held sacred. When he finished, he sat in silence for several minutes, staring at the photographs of the American bazooka, this crude tube that had somehow accomplished what years of German engineering could not. "Get me Dippel. Ing. Friedrich Weber," he told his adjutant. "Tell him to bring everything from the Panzerfaust program. And contact Hassag Industries. We're going to need production facilities immediately." Friedrich Weber arrived within the hour, a thin man in his early 50s, whose hands still bore the oil stains of workshop labor. He'd spent the past 18 months developing the Panzerfaust, a single-use anti-tank weapon that showed promise but remained plagued by manufacturing complexity and resource constraints. Now, spreading Richter's photographs across Müller's desk, he saw something that made his carefully constructed development timeline collapse into irrelevance. "They've solved it," Weber said quietly, tracing the bazooka's simple tube with one finger. "Everything we've been struggling with for years. They've simply—" "Can we copy it?" "Copy it?" "Oberst. We must copy it. This weapon represents a fundamental shift in infantry anti-tank capability. But copying it exactly would be a mistake. We need to improve it." Müller's expression darkened. "Improve it? Herr Weber, the American weapon costs half what our anti-tank rifles cost and kills tanks 3 times as effectively. What exactly needs improving?" "The caliber." Weber pulled out specifications for the Panzerfaust's warhead, a large 88mm shaped charge that had shown devastating effectiveness in tests. The Americans use a 60mm warhead, adequate against Panzer IIIs and early Panzer IVs, but insufficient against newer Soviet heavy armor. If we're developing a weapon from scratch, we should build it for the threats we'll face in 1944 and beyond. We don't have time for development from scratch. The Americans are already producing these weapons by the thousands. Then we adapt quickly, use the American design as our template, but marry it to our existing 88mm warhead, the one from the Hauptmann program. Weber was already sketching as he spoke, his pen flying across paper. The Hauptmann's warhead is proven. We've been developing it since 1942. It penetrates over 100mm of armor. Simply adapt it to fit a tube launcher instead of the wheeled carriage system. The Hauptmann, officially the Raketenwerfer 43, had been Germany's answer to the anti-tank problem, A sophisticated piece of engineering, it used an 88mm rocket fired from a breech-loaded launcher mounted on a small wheeled carriage. Effective, yes, but requiring a crew of 3, weighing nearly 300 pounds with its carriage, and costing over 800 Reichsmarks to produce. It was everything the bazooka was not: complex, expensive, crew-intensive. But the warhead itself was excellent. And if that warhead could be married to the bazooka's simple tube launcher, how quickly can you produce a prototype? Müller asked. 2 weeks, perhaps 3. The challenge isn't the launcher. That's just a steel tube, as the Americans have shown. The challenge is the ignition system. The Americans use batteries, which our troops report as unreliable in extreme cold or after rough handling. We should use a magneto system instead. A magneto adds complexity. Necessary complexity. A magneto can't go dead, can't corrode, can't fail because someone forgot to replace the battery. It's one component, Oberst, and it makes the weapon more reliable under field conditions. Müller considered this. Germany's experience on the Eastern Front had taught brutal lessons about weapon reliability in extreme conditions. Mechanisms that worked perfectly in temperate testing ranges seized in Russian winters. Batteries froze. Electrical systems failed. If the magneto improved reliability, it was worth the added complexity. Approved, but nothing else. I want the design as close to the American original as possible. Simple, manufacturable, deployable immediately. Weber nodded, already lost in calculations. We'll need to lengthen the tube to accommodate the larger rocket, perhaps 160 centimeters instead of the Americans' 137, and we'll need a blast shield. The 88mm rocket produces more exhaust than the American 60mm. Without protection, the operator will suffer burns. Then add a shield, but make it simple. A steel plate, nothing more. Understood. And the name? Müller smiled grimly. The troops will name it themselves. They always do. But officially, Raketenpanzerbüchse, rocket anti-armor rifle. The Americans call theirs a bazooka after some comedian's musical instrument. We'll call ours what it is, a tool for destroying tanks. Within days, prototypes were under construction at Hassag facilities in Leipzig. The company that had manufactured the Pupchen's components simply scaled their operation to produce tube launchers instead of wheeled carriages. The 88mm warhead required no modification beyond adapting its fins to stabilize in flight after launch from an open tube rather than a closed breech. The magneto ignition system posed the greatest challenge. German engineers had to design a hand-cranked generator small enough to fit in a pistol grip, powerful enough to produce the electrical charge needed to ignite the rocket motor, and durable enough to survive battlefield conditions. They borrowed technology from aircraft starters and motorcycle engines, miniaturizing and hardening until they had a component that met requirements. By March 1943, barely a month after Richter's report reached Berlin, the first Raketenpanzerbüchse 43 prototypes were ready for testing. Weber himself travelled to the proving grounds outside Berlin, carrying 3 launchers and 20 rockets in a truck that looked like it might fall apart before reaching its destination. Germany's industrial capacity was already straining under the weight of war, and even priority projects suffered from material shortages. The test proceeded methodically. Engineers positioned captured Soviet T-34 tanks at varying ranges and angles, simulating battlefield conditions. Weber selected operators who had never seen the weapon before, deliberately choosing soldiers with minimal technical training. If the design was truly simple enough, anyone should be able to use it. The first operator, a young Gefreiter from a Panzer Grenadier unit, received 5 minutes of instruction. Load from rear, connect the wire, aim, fire. The soldier hefted the launcher, positioned it against his shoulder, and aimed at a T-34 positioned 100 meters downrange. Fire when ready, Weber called. The soldier squeezed the trigger. The magneto generated its charge, the rocket motor ignited with a roar that rattled windows in the observation bunker, and the 88mm projectile streaked downrange trailing white exhaust. Impact came 2 seconds later. The shaped charge punched through the T-34's side armor and detonated inside, the explosion blowing the turret half off its mount. Silence. Then cheering from the observation bunker, officers and engineers who understood immediately what they'd witnessed. A weapon simple enough for a private to use, powerful enough to destroy the most advanced Soviet tank in service, ready for mass production within weeks. Weber felt no elation, only a cold calculation of numbers. If they'd had this weapon in 1941, at the start of Barbarossa, how many panzer crews would still be alive? How many battles might have turned differently? The bazooka had existed as an American concept since May 1942. Germany was copying it in March 1943. 10 months of delay. 10 months during which Soviet armor had dominated battlefields while German infantry died trying to stop tanks with weapons that couldn't penetrate. But there was no changing the past, only learning from it. Testing continued throughout the day. 20 rockets fired, 18 successful penetrations against targets ranging from light French tanks to heavy Soviet KV-1s. The 2 failures came from rockets that tumbled in flight due to manufacturing defects in the fins, something that could be corrected through better quality control. The magneto system proved reliable, generating consistent charges, even after the launchers were deliberately dropped, submerged in water, and left in sub-freezing temperatures overnight. By April, the weapon had a new name, not the official Raketenpanzerbuchse 43, which soldiers found too cumbersome, but Panzerschreck, Tank Terror. The troops on the Eastern Front, receiving the first production models in May, embraced it immediately. Here, finally, was something that worked. Something simple, something that gave infantry a fighting chance against Soviet armor that had dominated the battlefield since 1941. But even as the Panzerschreck entered service, Weber understood the deeper truth Richter's report had revealed. Germany was copying American simplicity, yes, but only after wasting years pursuing German complexity. And more damning, even with the design handed to them, even rushing production, Germany could not match American manufacturing capacity. It helps us continue producing in-depth content like this. By the end of 1943, Germany had produced approximately 25,000 Panzerschrecks, an impressive number, particularly given the strain on German industry from Allied bombing and resource shortages. Weber took some pride in that achievement. Hassag's factories worked around the clock, workers assembling launchers and rockets with the desperate efficiency of a nation fighting for survival. 25,000 Panzerschrecks. The Americans, that same year, produced over 300,000 bazookas, a 12-to-1 production ratio. And American factories were just reaching full capacity while German production peaked and then began to decline as bombing campaigns intensified and raw materials grew scarcer. The mathematics were inescapable. Every German innovation, every improvement, every technical advancement meant nothing if it couldn't be produced in sufficient quantities. The Panzerschreck was a better weapon than the bazooka. The 88mm warhead penetrated thicker armor. The magneto ignition was more reliable. German manufacturing tolerances produced more consistent rockets with fewer failures. But better didn't matter when outnumbered 12-to-1. Weber sat in his office late one evening in November 1943, reviewing production figures and casualty reports. On the Eastern Front, Panzerschreck teams had knocked out over 2,000 Soviet tanks in 6 months, an impressive tally. But Soviet production had replaced those losses within weeks. The Red Army fielded T-34s faster than Germany could destroy them, and behind Soviet production stood American industrial might, shipping tanks and equipment through Lend-Lease at rates that dwarfed German capacity. The Western Allies were preparing for invasion. Everyone knew it. France, probably. Normandy, most likely. And when they came, they'd bring Shermans and Cromwells and all the other crude, mass-produced tanks that American and British factories churned out with assembly line efficiency. Tanks that German panzers could destroy in single combat. Tanks that didn't matter because for everyone destroyed, 3 more appeared on the battlefield, and American infantry would carry bazookas, thousands of them, tens of thousands. Every squad equipped with weapons that gave them portable anti-tank capability. Germany had the Panzerschreck, yes, but in numbers that could never match Allied production. The mathematics of industrial war were grinding Germany into dust, one production statistic at a time. A knock at the door pulled Weber from his calculations. His assistant entered, carrying a folder stamped with red security markings. Herr Dippel, Ing. Intelligence has received reports from Italy. American forces have introduced a new model, the M9. It uses a magneto-ignition system. Weber took the folder, scanning the technical assessment inside. The Americans had observed the Panzerschreck's magneto system, recognized its superiority over battery ignition, and incorporated it into their own design. Just as Germany had copied the bazooka's simplicity, America was now copying Germany's improvements. A circle of adaptation, each side learning from the other, iterating designs in response to battlefield feedback. But America could iterate faster. American factories could retool in weeks, implementing changes across entire production runs. German industry, strained and bombed and starved of resources, took months to make modifications that American plants accomplished in days. "They're learning from us," the assistant said. "No," Weber replied quietly. "They were always going to make these improvements. We just made them first. The difference is they can implement lessons faster than we can. They have the industrial capacity to evolve their designs in real time, adjusting to battlefield conditions, while we struggle to maintain production of existing models." He set the folder down, feeling the weight of futility settle over him. The Panzerschreck was a fine weapon. German soldiers praised it. Allied tankers feared it. But in the grand calculus of war, individual weapons mattered less than the systems that produced them, and Germany's system was breaking, while America's was just reaching peak efficiency. "Draft a memo to Oberst Müller," Weber said. "Recommend we focus on increasing Panzerfaust production instead of Panzerschreck. The Panzerfaust is single-use, simpler to manufacture, requires fewer materials per unit. If we can't match Allied launcher production, at least we can flood the front with disposable weapons." Abandon the Panzerschreck program? Not abandon. Scale back. Prioritize quantity over capability. It's what the Americans did from the start, and it's working for them. We should have learned that lesson in 1942. Instead, we copied their weapon in 1943 while maintaining our philosophy of quality over quantity. We built a better bazooka. We should have built more Panzerfausts. The assistant nodded and left to draft the memo, leaving Weber alone with his thoughts and the reports that told the story of industrial decline. The Panzerschreck would remain in service, would continue to destroy enemy armor, would earn its reputation as tank terror, but it would never be produced in numbers sufficient to change the war's trajectory. Germany had learned American simplicity too late, applied it too hesitantly, and lacked the industrial foundation to leverage it effectively. By December 1943, the pattern was clear to anyone who looked at the numbers without ideological blinders. Germany entered the war with superior weapons, superior training, superior tactical doctrine. But the Allies entered with superior production capacity, and in industrial warfare, capacity trumped quality every time. The nation that could replace losses faster, that could equip more soldiers with adequate weapons, that could sustain production despite setbacks, that nation would win. The bazooka had revealed that truth in stark, undeniable terms. A crude weapon, hastily developed, produced by the millions. And Germany's response, the superior Panzerschreck, produced by the thousands. The mathematics weren't complicated. They were just painful to acknowledge. Weber closed his production reports and turned off the desk lamp, leaving his office in darkness. Outside, Berlin slept fitfully under blackout conditions, waiting for the next bombing raid. The war had turned. Not at Stalingrad, though that was where the Wehrmacht's advance broke. Not in North Africa, though that was where Axis forces lost their foothold. The war had turned in American factories, in production lines that transformed raw materials into weapons at rates Germany couldn't match. The bazooka wasn't just an anti-tank weapon, it was a declaration, a statement of industrial philosophy. Build adequate tools quickly, in overwhelming numbers, and trust that quantity would compensate for individual limitations. Germany had spent decades perfecting the craft of weapon design, creating masterpieces of engineering that required skilled labor and precious resources. America had spent 6 months simplifying that craft into something any factory worker could assemble, any soldier could use, and any logistics system could supply. And in that simplification lay victory. The Eastern Front consumed Panzerschrecks as fast as factories could produce them. Every day brought reports of successful tank kills, German infantry finally equipped to face Soviet armor on something approaching equal terms. But every day also brought reports of losses, launchers destroyed, operators killed, units requesting replacements that took weeks to arrive because production couldn't keep pace with demand. Meanwhile, American bazookas flooded the Mediterranean theatre. British forces in Italy carried them. Free French units carried them. Partisan groups behind German lines carried them. Weapons parachuted in by the hundreds, simple enough that resistance fighters with no military training could learn to use them into an afternoon. The simplicity that German engineers had initially dismissed as crude became a strategic asset, allowing rapid distribution and deployment across theatres and armies, and Allied forces who needed no specialized training to become effective. By early 1944, as the Allies prepared for the invasion of France, Weber received intelligence reports that made him want to weep. American production of bazookas had accelerated, not just the weapon, but the entire infrastructure supporting it. Training programs that could teach a soldier bazooka operation in 2 hours. Logistics systems that could deliver rockets to frontline units within days of requisition. Maintenance procedures so simple that field repairs required nothing more than basic tools and common sense. Germany had copied the weapon, but America had built a system around the weapon, integrating it into their military doctrine so thoroughly that it became more than just another tool. It became foundational to how American infantry fought, how they approached armored threats, how they structured their tactics and training and logistics. And that system, Weber realized, was what Germany could never copy. Because systems required infrastructure, and infrastructure required resources, and resources were exactly what Germany lacked, the bazooka could be reverse-engineered. The Panzerschreck proved that. But the industrial philosophy behind the bazooka, the commitment to simplicity and mass production and adequate but sufficient design that couldn't be copied by a nation already committed to complexity and craftsmanship and resource-intensive perfectionism. The invasion came on June 6, 1944. Normandy, as predicted, and American infantry came ashore carrying bazookas, thousands of them, every squad equipped with portable anti-tank capability. German defenders, dug into hedgerows and fortified positions, found themselves facing not just overwhelming numbers of tanks, but overwhelming numbers of infantry who could kill those tanks. The Panzerschreck teams fought well, knocked out dozens of Shermans and Cromwells, earned their reputation. But there weren't enough teams, weren't enough launchers, weren't enough rockets to sustain the defense against wave after wave of Allied infantry equipped with weapons that just kept coming. Weber watched the reports from Normandy with the detachment of someone who'd already accepted defeat. The weapon he'd helped develop was performing exactly as designed. German soldiers loved it. Allied tankers feared it. But none of that mattered because Germany couldn't produce Panzerschrecks fast enough to equip more than a fraction of its forces, while America equipped nearly every infantry squad with bazookas. The mathematics had been clear from the start. He'd simply refused to see them. By autumn 1944, as Allied forces pushed toward Germany's borders and Soviet armies closed from the east, the Panzerschreck program had become a bittersweet symbol of German engineering, a weapon born from copying American simplicity, improved through German innovation, undermined by German industrial limitations. It worked. It killed tanks. It gave infantry a fighting chance, but it came too late, in too few numbers, to change anything that mattered. Weber sat in his office one final time before evacuation orders forced the Weapons Development Division to relocate south, away from the advancing Soviet front. He pulled out Richter's original report from February 1943, the photographs of the captured bazooka, the analysis that had sparked the entire Panzerschreck program. Reading it again, 20 months later, he saw all the warnings they'd ignored. Richter had written, "This weapon reveals a fundamental difference in how America approaches war. They build what works, not what's perfect. They build what can be mass-produced, not what showcases engineering brilliance." They build with understanding that adequate weapons in overwhelming numbers will defeat superior weapons in limited quantities. Weber had read those words in March 1943 and thought, we can do better. We can build a superior version, incorporate improvements, create something that combines American simplicity with German quality. And they had. The Panzerschreck was better than the Bazooka in nearly every measurable way. But better didn't matter when outnumbered. Better was a luxury Germany could no longer afford. What Germany needed was more, and more required an industrial philosophy that ran counter to everything German engineering stood for. The Americans had understood that from the beginning. They'd built a crude tube, added a simple rocket, and produced it by the millions before Germany finished perfecting its anti-tank rifles. And in that prioritization, speed over perfection, quantity over quality, adequacy over excellence, they'd won the industrial war before the shooting ever started. Weber packed his documents into a worn briefcase, preparing for the evacuation that would take him south to Bavaria, where weapons development would continue in increasingly desperate circumstances. Outside, Berlin was dying, not in a single catastrophic moment, but in the slow grinding collapse of a nation that had bet everything on superior weapons and lost to superior production. The Panzerschreck would continue to fight, would continue to kill tanks, would continue to give German infantry a tool they desperately needed, but it would do so as a monument to a lesson learned too late. In industrial warfare, the side that could build adequate weapons fastest won, regardless of who built the best weapons eventually. Somewhere in America, factories were still producing bazookas by the thousands, simple steel tubes that cost $40 and killed tanks. And somewhere in Germany, factories struggled to produce Panzerschrecks by the hundreds, superior weapons that cost 3 times as much and killed tanks just as dead. The mathematics had always been clear. Weber had simply spent too long refusing to accept them. Now, with Soviet artillery rumbling in the distance and American bombers circling overhead, acceptance came easy. Too easy. The kind of clarity that arrived after defeat was certain, when understanding changed nothing because the time for change had passed. He picked up his briefcase and walked out of his office for the last time, leaving behind reports and calculations and all the engineering data that proved German weapons were better. Better didn't matter. It never had. The Americans had known that in 1942. Germany learned it in 1944. And the 2 years between those revelations had cost everything. The war ground on toward its inevitable conclusion. The Panzerschreck remained in service, killing Allied tanks until the final days, earning its nickname as Tank Terror right up to the moment Germany surrendered. But history would remember it not as a German innovation, but as a German copy. A recognition, too late and too limited, that American simplicity had beaten German complexity in the only competition that mattered. The race to arm an army before the enemy destroyed it. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.